So our semester exam review does start off with the x and y intercepts at 4-5. And if you've held on to your notes, you can just use your notes and they'll help you out as far as remembering how to do these. But for the x and y intercepts, we have to remember that if it's on the x-axis here, their y value is 0, and if it's on the y-axis, your x value is 0. So we find the x-intercept for when y is 0. So go ahead and write that out for me. And then from there, we're just going to replace y with 0. So if it's x minus y equals -3, it's going to be x minus 0 equals -3. I love 0 because the 0 just disappears. And what's the only thing we're left with on that side? X, you got equals -3. Now for this one, it's an ordered pair. So it's going to be -3, 0 as the ordered pair because x is -3, y is 0, and we're good. That's 1 point for our x-intercept. And now the next one we find is your y-intercept. And we find that for when x equals 0. And same exact thing, if your formula says x minus y equals -3, we're going to get 0 minus y equals -3. Once again, I love 0 because he just disappears, but what type of y are we left with?
Negative.
You got a negative, so what do I have to do to get y to become a positive? Divide. You got to divide both sides by -1, -1, -1's cancel, and y equals 2 negatives, make it a +3. And now we're right back to, oh, shouldn't have boxed that in so soon. There we go, +3. I need to still write my ordered pair now. So as far as that goes, your x value is 0 and your y value is 3, so it'd be 0, 3. And now to graph the line, we're just going to plot those 2 points. So -3, 0 is on your x-axis because x is your variable there. So x-axis, -3 is left 3. Your y is 3, so 0, 3 sends you to the origin, then up 3. And then just as best you can, just make a line through those 2 points, and you're good. So that's how you find your x and y intercepts. It's a really quick way in order to graph the lines too, because all you have to do is just remember if we're finding the x-intercept, y is 0. So do the next one. The x-intercept, y is 0. So if it says x plus 3y, it's going to be x plus 3 times 0 equals 3. Once again, I love 0 because anything times 0 is what? 0. There we go. So it cancels out and we're good. Okay, so now we're just left with x here on the left side equals 3. And so this ordered pair, x always comes first, is 3 for x, and then y is 0. And now our y-intercept is for when x is 0. So if your formula says x plus 3y, it's going to be 0 plus 3y equals 3. Once again, I love 0 because 0 disappears, but y is a 3y. So what's our last step? You got divide both sides by 3. 3's cancel, y equals 3 divided by 3 is 1. And so this ordered pair is going to be 0 for x, and then y is 1. There we go. And now we just plot those 2 points. So 3, 0 is on your x-axis. So we go to the x-axis, and +3 is right 3. Alright, your y value here is 1. So on the y-axis, we go up to 1. Or 0, 1's the origin, then up 1. And now, once again, just do your best to make a straight line there. Alright, for 4-6, it talks about functions. And the very first thing we're asked to do is determine whether each relation is a function. So just a real quick reminder, if you'll make yourself a note, function means domains, which are your x values, cannot repeat. Now one way to see if it repeats for a graph is the vertical line test. So way back in 4-6 we talked about how if you hold your pencil vertically to your graph, it will show you if it touches the x points more than once. As far as it goes, your first graph, would it pass or fail the vertical line test? How many points does it touch at a time? Just once. So does it pass or fail? Pass. You got it. So for the first one here, all we have to do is put yes, it is a function. Now, For our next one, it's a vertical line, so if I put a vertical line on top of it, it touches way more than one point. It touches all the points. So would it be a function? Nope, you got it. So no, because it touches more than one point. Alright, now for a mapping. Once again, we only care about the domain, which is just your x values. So we're going to look at just your x oval. How can you tell if a number is being used more than once? The line. So if you look here at -1, if it has two lines coming from it, that means it's used twice. So is this one a function? No, you got it. Alright, now over here, once again, we should look at just your x value. So x, x, x. So if we have 4, 2, and 6, and they're all different, is it a function? Yes, you got it. Alright, now this one. If I were to graph -2x plus 4y equals 0, what shape would it make? We've graphed these a whole big bunch. What does it make? Go back to what you just did. Look at your first two examples. What does it make? Huh? Just what shape is it? Okay, it's a line, right? It makes a line. Yes, we all agree your first two examples make a line. So from there, this would graph to make a line. Would a line pass or fail a vertical line test? Huh? Well, go back up and look at your first two examples. Well, this one is just a diagonal line. If it's just a diagonal line, it would pass it. So it would be a yes. The only time it is a no, the only variable there is an x. As long as you have a y value involved, it's always going to be yes. Okay, so for our last part of the 4-6 was our function notation. It gives us these two equations, f of x equals 2x minus 4, and g of x equals x squared minus 4x. And then asks us to find f of 4. So we're going to use the f function. So we're going to use this guy right here and say f of x formula was 2x minus 4. So if you look from the original, f of x became f of 4. We just replaced x with 4. So over here, we're going to replace this x with 4. So if it's 2 times x, it's now going to be 2 times 4 minus 4. And we only deal with just this right side of the equal sign. So 2 times 4 is 8. Minus 4 drops down. 8 minus 4 is 4. We're done. So all we have to do for function notation is just substitute. That's all it is you just take the variable, and it gives you a value for it, like 4. You plug it into your expression. Your 2x becomes 2 times 4, and then just order of operations. Multiply, subtract, you got it. And same thing over here for this one. We have g of 2. So we're going to use our g function here. So right above that, I'm going to write g of x equals x squared minus 4x. And every time now we see an x, we're going to have to replace it with 2. So if you notice, I have x becomes 2, and I have 2 x's. This one and this one. Both of them are going to get replaced with 2. So it's going to be 2 squared minus 4 times x is now 4 times 2. So we replace both x's with 2. And now once again, order of operations kicks in. We've got to do exponents first. 2 squared is 4. Bless you. Minus 4 times 2 is 8. 4 minus 8 is a negative 4. And once again, we're good. So anytime it's function notation, it's just substitution. So for this next set, we're looking at 5-1, which is slope. And we're asked to find the slope of each set of ordered pairs or the graph. So because we're asked to find just slope, it's just going to be just the slope formula, which is m equals y2 minus y1 over your x2 minus x1. And every single ordered pair, we got x1, y1, x2, y2. Y2 is a negative 14, minus y1 is 18, over x2 is 10, minus x1 is 6, and then from there we just subtract. So negative 14 minus 18 is a negative 32, over 10 minus 6 is 4, negative 32 divided by 4 is negative 8. Alright, so for the next one, still still wanting the slope, so still y2 minus y1 over x2 minus your x1. You don't have to rewrite the formula, I just do so we can all see it. So it's x1, y1 for your first order pair, x2, y2 for your second order pair, and now y2 is a negative 13, it's going to be minus a negative 8. And now x2 is negative 1 minus x1 is negative 11. So now negative 13 minus a negative 8 is like negative 13 plus 8, which is negative 5. And now negative 1 minus a negative 11 is negative 1 plus 11, so that gives us 10. And then negative 5 over 10 gives us a negative 1/2. And we're all good. So for the next two with the graphs, we're just going to have m equals rise over run. Because your first one goes up to the right, is it positive or negative slope? Positive, because it goes up to the right. And now we just count. So we're going to count from this one to this one. The same way we read a book, we go from left to right. And we kind of make a triangle out. So we're going to count up 1, 2. So the rise is 2. Over the run is 1, 2, 3, 4, 5, 6, 7. And we're good. That's your answer. 2 over 7. Can't reduce. Alright, next one. Because it goes down to the right, it's going to have a negative slope. So we're still looking at rise over run. We're going to go from the point to the left to the point on the right, which means we have to go down for the rise to make it negative. And then we'll count how many we run right. So always run right if we can help it. So we're going to go down 1, 2, 3. So negative 3 over, and then we run 1, 2, 3. And negative 3 over 3 can reduce. What is negative 3 divided by 3? Negative 1, and we're good. Right. So for 5-3 slope-intercept form, we're asked to find the slope and the y-intercept, so find the m and the b for each equation, then graph each equation. So your first one already looks like slope-intercept form, but it's already in that y equals mx plus b form. So when it looks like slope-intercept form, you're good to just find your m and your b. So what's our m for this one? You got 2, and we put all whole numbers over 1, so 2 over 1. What's our b? So 0, negative 4. And now, when you go to graph it, we begin with b. So now b sends us to 0, and then down to negative 4. And our slope is 2 over 1, which means it's going to send us up 2, right 1. So up 2, right 1, up 2, right 1. Take a straight edge, make a nice long line, arrows on each end. Alright. For the next one, same thing. It already looks like our y equals mx plus b form, because y is already by itself. And now all we have to do is just state your m and your b. So what's m? You got negative 1, put all integers over 1, and now b is going to be what? You got it. So 0, 5. Once again, we begin with b, so go to the origin, then up 5. Then our slope tells us, because it's negative, to go down 1, right 1. So down 1, right 1, down 1, right 1. Take a straight edge, make a nice long line across your graph paper, arrows on each end. So now for these next two examples, write them out to the side, that way we have a little bit more room to show our work. 6x plus y equals negative 1. And the first thing we want to do is get y by itself. Y equals mx plus b is how it needs to look. So with your first one, y is always going to stay on the left because y is already on the left. So my y drops down. He's already a positive y. He's good to go. Now who needs to be on the other side of the equal sign? You got, so positive 6x becomes a negative 6x. We drop down our minus 1. Technically, at this point, you could divide everybody by 1, but is my y already by itself? Yeah, so we don't have to. We can go ahead and just trust that, state our m and our b. So m is going to be negative 6 over 1, and b is going to be 0, negative 1. And now we begin with b. So b sends me down 1, so 0, negative 1. And now my slope is negative, so it's going to send me down 6, right 1. So down 6. 1, 2, 3, 4, 5, 6. Oh, it puts me off the graph, and then right 1. So if I can't go down and right anymore, where else could we go? you got up and left. So up 1, 2, 3, 4, 5, 6 over 1. And now make a nice long line through those 3 points, and we're good. And now the last one for us. Same thing as before. I'm going to rewrite it out to the side because it is not in slope-intercept form. And we need it to be in slope-intercept form. So I want it to look like my y equals mx plus b. So my y is going to stay on the left. And because this time it's a minus 3y, we have to keep negative 3y on the left. So we got to keep that whole part with our y, the sign in front, the number in front, and the y equals. And now we put the x to the other side. So positive 5x becomes a negative 5x. Oh, negative 5x. And then we drop down our minus 12. And now y instead of get y by itself, we divide everybody up here by negative 3. Negative 3's cancel, and y equals negative 5 over negative 3. Two negatives will make it positive, so it just becomes positive 5 over 3 x. And now negative 12 divided by negative 3 becomes a positive 4. So our slope for this one's going to be 5 over 3. And our b is going to be 0, 4. Once again, we're going to begin with b. So b sends me to 0, then up 4. And now once again, our slope is positive, so it goes up 5 and then right 3. But if you notice, if I go up 5, it goes 1, 2, 3, 4, 5, and then over 3, 1, 2, 3. It puts me off the graph paper. Technically, though, I've told us this in the past, if you want to make that point out to the side so you know which way it goes, you can. But if I can't go up and right, where else can we go? Down and left, you guys. So we're going to go down 5, 1, 2, 3, 4, 5, and then left 3, 1, 2, 3. And now just make a straight edge. You can make a point just through those two on the graph. I'm going to make mine go all the way up though. And we're good. We're good. Okay. So 5-4 asks us now to write the slope-intercept form. And remember, that's just your y equals mx plus b. For the equation of each line that goes through a given point with the given slope. So as far as this one goes, it goes ahead and tells me my slope. So we know for this one, m is going to be negative 1. So if it tells me my slope, which is m, what do we still need in order to write an equation of slope-intercept form? We have m, what do we still need to find? B, you got it. We still need to find b. So we're going to find our y-intercept by using our slope-intercept form, y equals mx plus b. We're going to use our order pair it gives us, x and y. So every order pair has an x and a y in it, and then we know m is negative 1. So we're going to plug all of this information into our formula and then solve for b. So y is 4, so y turns into 4 equals m is negative 1, so m becomes negative 1. They're side by side, so they're being multiplied, so negative 1 times x is negative 2, and then plus b. And then from here, these next steps are identical for every single thing we do in 5, 4, 5, 6, and 5, 7. We multiply, so negative 1 times negative 2 makes a positive 2, so 4 equals positive 2 plus b. And now if it's a positive 2, how do I get rid of it? Minus 2. You got so minus 2, 4 minus 2 is 2, equals, these 2's cancel, b. So now I have m is negative 1, b is negative 2, or sorry, positive 2, that was my thought, b is positive 2. What's our final formula? We're going to say y equals, what comes after equal sign? You got your negative 1, and what has to stay with my negative 1? X. You cannot forget your x. We're back to the lesson where I said don't forget your x's. You may want to forget your x's, but you cannot forget this x. And then your b is plus 2. So negative 1x plus 2, and we're good. And this one over here works the same exact way. So same thing as before. First thing we got to find is slope. It gives me my slope this time. So m is negative 3 over 2. Now we got to find our y-intercept, and we do that by using the slope-intercept form, y equals mx plus b, and our first order pair, which is x and y, and then our m negative 3 over 2. Plug it all in. You all did a great job with that part. So y is 1 equals m is negative 3 over 2 times x is negative 2 plus b. First thing we've got to do is multiply. Negative 3 over 2 times negative 2 makes a positive 3 plus b. Now because it's positive 3, we subtract 3 from both sides, and 1 minus 3 is negative 2. 3's cancel, so it equals just b left over here, and we're good. Last step is to write our final equation in slope-intercept form. So we get y equals m is a negative 3 over 2. Have to keep the x beside of it, and b is a negative 2, and we're good. Alright, for this next part where we have brought the slope-intercept form given 2 points, the first thing we still do is find slope, but this time we have to use the slope formula to find the slope. So it's going to be your m equals y2 minus y1 over x2 minus x1. And then your order pairs are x1, y1 for your first order pair, and then x2, y2 for your second order pair. And then m equals y2 is going to be 5 minus y1 is 2 over x2 is negative 2 minus, and then your x1 is a negative 1. And we're good. So now we just simplify it down. 5 minus 2 is 3 over negative 2 minus the negative 1 is negative 1. 3 divided by negative 1 is negative 3. Oh, there we go. And once again, if you put that whole thing into the calculator, it gives you negative 3. So there we go. So we have m is negative 3. Now this next part to find the y-intercept is the same thing we did on the last 2 examples. We're going to use our slope-intercept form, y equals mx plus b, and the first order pair, just because it's nice to have a consistent pair of points to always grab the first set. And now your y is 2 equals, we said m was negative 3 times x is negative 1 plus b. And now 2 equals negative 3 times negative 1 is positive 3 plus b. Positive 3 means we subtract 3 from both sides, and 2 minus 3 is negative 1 equals, and then 3's cancel, b. So now we have our slope, we have our y-intercept. Last little bit, write the formula. So we're going to have y equals, and it's m, which is negative 3. The x has to stay with it, so can't forget your x. And then minus 1 is your b, and we're good. So as far as it goes, the first thing we do for this one is find our slope. I'm not going to rewrite the formula because I've already written the formula 3 times today, but your m's going to be your x1, y1, x2, y2 for order pairs, and then it starts with y2, so 2 minus y1 is a negative 1 over x2 is 1 minus a negative 2. Hit that button. Alright, m equals negative 2, or sorry, positive 2 minus a negative 1 is 3. 1 minus a negative 2 is 3. 3 divided by 3 is 1. Oh, positive 1. I have that one notch there. That makes it look like it's negative. There we go. Now we find our y-intercept. We use our slope-intercept form, y equals mx plus b, and our first order pair, and our slope. So y1 is negative 1 equals m is positive 1, x is negative 2 plus b. Negative 2 times 1 is negative 2 plus b. Because it's a minus 2, we add 2 to both sides. So negative 1 plus 2 is positive 1 equals 2's cancel, b. There we go. So your final equation is going to say y equals m is 1x, and then b is plus 1. So we're all good. There were 1's everywhere. Don't forget your x or your y. So now, I did type in the wrong title for that one. So if you can, just write 5-6 and mark out the 4. It was 5-6 for parallel and perpendicular lines. I just accidentally copy and pasted it wrong. So parallel means same slope. So below parallel, I'm going to write same m. And then for perpendicular, there's 2 things we have to do. Does anyone remember the 2 things you have to do for perpendicular lines?
Change the sign,
You got change the sign, flip the fraction. So change signs. If it's positive, we make it negative. If it's negative, we make it positive. And then we flip the fraction. And from that, it's the same exact steps we had on the last 4 examples. We're going to find our slope, we're going to find our y-intercept, we're going to write our final equation. So the first thing we've got to do for this one is it says it goes through the point 54, which is our x and our y, and it's parallel, which means same slope, to y equals 9/5 x. So if its slope is 9/5, our slope is going to be 9/5. And now this next part's the same thing we've been doing. It's the 5th time we're going to do it for our y-intercept. We take our y-intercept, we use our y equals mx plus b, plug in our ordered pair and our slope into our formula and solve for b. So y is 4 equals m is 9/5 times x is 5 plus b. 9/5 times 5 is 9, so 4 equals 9 plus b. Because it's a plus 9, we make it minus 9, minus 9. 4 minus 9 is negative 5, equals 9's cancel, b. So now we have our m is 9/5, so y equals 9/5 x, and our b is a minus 5. And we're good. Alrighty, so now for our next one, our slope's the first thing we're going to find, so m equals, and now it tells us it's parallel, so same slope. So if this slope is 4, our slope's also going to be 4, and we're good. Now we're right back to our y-intercept, which we're going to use our slope-intercept form, y equals mx plus b, and our ordered pair where we have our x and our y, and then our m. So y is 2 equals m is 4 times x is 3 plus b. 4 times 3 is 12, so 2 equals 12 plus b. Minus 12 from both sides. 2 minus 12 is negative 10, equals 12 cancel, and we get b. So now last step, write our final equation, which is going to be y equals, your m is 4x, and your b is minus 10. And we're good. So for perpendicular lines, it's the same thing. First thing we're going to do is find our slope, but this time the slopes are different. So if this line slope is a negative 3/2, our slope's going to be positive, because we first going to do is change the sign. So a negative slope is going to become positive, and if that's 3/2, what's our slope going to be? 2/3, you got it. So we have our m, and now the y-intercept is the same thing. We just keep doing that part there where we use our slope-intercept form, plug it in, find our b. So we got x and y. So y is 5 equals m is 2/3 times x is 3 plus b. 2/3 times 3 is 2, so 5 equals 2 plus b. Because it's positive 2, now make it minus 2, minus 2, 5 minus 2 is 3. 2's cancel, equals b. And its final equation is going to say y equals, our new slope is the one we use, so 2/3, so 2/3 x. And our b is positive 3, so plus 3, and we're good. And for our last one of this set for 5-6, once again we're asked to find the point that's perpendicular. So if this slope is a negative 3, because it's negative, our slope's going to be positive. So the first thing we do is change the sign. But what's that negative 3 technically over right now? 1, you got it. So if it's negative 3/1 and I flip it, what's my slope going to be? 1/3. There we go. So now we have our m, and this beautiful y-intercept is the same steps we've had. We find b by plugging into our slope-intercept form, and we're good. So y is negative 3 equals m is a positive 1/3 times x is 3 plus b. Alright, 1/3 times 3 is 1, so negative 3 equals 1 plus b. Because it's a positive 1, we minus 1, minus 1, negative 3 minus 1 is negative 4, equals 1's cancel, and then b. Last step now is to write our formula. Y equals, our m is a positive 1/3 x, our b is a minus 4, and we're good. A little bit. So, our next part is the scatter plots. And the first thing we're asked to do is determine whether each graph shows a positive correlation, a negative correlation, or no correlation. If there's a positive or negative correlation, describe its meaning in the situation. So the first one we are given are calories burned during exercise. And we have time minutes being exercised and the calories being burned, what type of correlation does it have? Positive, you got it. So now, because it's positive, we have to give it its description. So we say, as time increases, calories burned increase. There we go. So as the time increases that we exercise, the calories burned increases. Now for our next one, for the library fines, if you notice it has like books borrowed on the x-axis, the fines in dollars. Can we put any type of line to that, positive or negative?
No correlation.
You got, so it's a no correlation, you got it. And for no correlation, we're done. We just get to move on to our next one. And we're looking at now an actual scatter plot. And on your semester exam, guys, I give you a scatter plot pre-made. I don't make you make a scatter plot on your semester exam because it takes way too much time. So it's going to look like this. So it's already going to be given to you. All we have to do is answer the questions. So it says determine what relationship, if any, exists in the data. Explain. So as far as that goes, you got, it has positive correlation. So that's its relationship, which means as the years increase, the average price of a baseball ticket increases. So as time increases, so does price of tickets. There we go. And now this next part, it says to use the points 1993 and 9.6. So 1993 and 9.6 and 1998 and 13.6. To write the slope-intercept form of an equation for the line of best fit in the scatter plot. So what it is, it just picked 2 points on that line of best fit, and now we need to find our slope, our y-intercept, and write the slope-intercept form. So, still our slope. Sorry, forgot to write slope there. And still your y2 minus your y1 over your x2 minus your x1. And now it's your x1, y1 for your first order pair, x2, y2 for your second order pair, and we're right back to what we've been doing. We just substitute and go from there. So m equals y2 is 13.6 minus y1 is 9.6 over x2 is 1998 minus x1 is 1993, and now we subtract. 13.6 minus 9.6 is 4. 1998 minus 1993 is 5. That can't reading, so we get 4/5 as our slope. Now we find our y-intercept. Same exact thing we've been doing. Your y equals mx plus b. Use our first order pair here, so y is 9.6 equals our m is 4/5 times our x is 1993 plus b. Alright, now I'm going to need your all's help for this one because I don't know it. 4/5 times 1993 is going to be a big old number, and we want to turn it to a decimal because it's a lot easier to work with if it's a decimal. So what's 4/5 times 1993 as a decimal? So 1,594.4, thank you, plus b. And now because it's a positive 1,500, we minus 1,594.4 from both sides. So this guy over here on the right side is going to cancel out. And now what's 9.6 minus 1,594.4? Negative 1,584.2 equals b. There we go. Last little bit. Oh, 0.8, thank you. Last little bit now, write our final equation. So this could be y equals m is 4/5 x. B is a negative 1,584.8. And we're good.